Chemistry time.
Hello everyone and welcome back to Chemist Tea Time. In today's discussion, we are going to be learning about the two main types of chemical bonding and how to name compounds. For this discussion, we'll be focusing on pure substances, meaning that they are comprised of a single species of matter and are not a mixture. Pure substances can be divided into two different types, elements and compounds. Elements are made up of a single type of atom, such as iron or helium. Compounds are substances where two or more different types of atoms have been chemically bonded together and cannot be separated by physical means. For our discussions, we are going to be looking at two different types of compounds, ionic compounds and covalent compounds. Let's start off by looking at ionic compounds, which is where electrons are transferred from one atom to another. This means that instead of each element having the same number of protons and electrons, one element will have more electrons and the other will have fewer. We call these species ions, and each ion will have a charge associated to them based on whether they have gained or lost electrons, keeping in mind that electrons have a negative charge. The number of electrons gained or lost depends on the element. Each element wants to have the same number of electrons as a noble gas, which has 8 valence electrons, because these are the most stable elements on the periodic table. So elements gain or lose electrons until they have the same number of electrons as the closest noble gas. For example, chlorine wants to have the same number of electrons as the closest noble gas, which is argon. So when chlorine forms an ion, it will accept 1 electron to have the same number of electrons as argon and giving it a -1 charge. We call this negative ion an anion. When we look at magnesium, the closest noble gas is neon, which comes before it on the periodic table. So magnesium will lose 2 electrons to have the same number as neon, giving it a +2 charge because it has more protons than electrons. Transition metals are the exception to this rule, since sometimes they don't end up with the same number of electrons as a noble gas, or may have several different types of ions with different charges, also known as oxidation states. In this case, the positive charge of the transition metal ion is represented as a Roman numeral in parentheses, such as with iron 3 or copper 1. We call this positive ion a cation. In general, metals tend to lose electrons and form cations, whereas nonmetals tend to accept electrons and form anions. In this way, we can easily identify an ionic compound because they almost always consist of a metal and a nonmetal. When an ionic compound forms, the individual ions of each element are arranged in a repeating structure of cations and anions known as a lattice. In an ionic compound, the ratio of cations to anions will vary depending on the charges. It is important to note that when these ions combine, the results must be a neutral species, meaning the number of positive and negative charges must be equal. An easy way to determine the number of each ion in an ionic compound is to swap the ionic charges to become the subscript of the opposite ion. For example, if we have calcium and bromine, calcium will form a +2 ion and bromine will form a -1 ion. So in order for this ionic compound to be neutral, we swap the charges and make them subscripts so that we have 2 bromine ions for every calcium ion. So this ionic compound would be CaBr2. Ions that are made up of a single atom, such as potassium, oxide, and chloride, are referred to as monatomic because each ion consists of a single atom. It is important to note that the chemical formula of an ionic compound represents the lowest possible ratio of cations to anions and is known as the formula unit. The other type of chemical bond is known as a covalent bond. In these bonds, electrons are shared between 2 atoms, and these occur between 2 nonmetal elements. Instead of forming lattices, covalent compounds exist as individual molecules. Some ionic compounds can also contain polyatomic ions, which are covalently bonded compounds that have a net positive or negative charge. This charge allows polyatomic ions to participate in ionic bonding. Some common polyatomic ions are shown here. Some examples of these ionic compounds that contain polyatomic ions include calcium carbonate and magnesium sulfate. You may notice that some of these ions only differ by the number of oxygen atoms. When there are 2 oxyanion species, such as SO3 and SO4, we use the suffix ate to denote the ion with more oxygen and the suffix ite to denote the ion with fewer oxygens. In the case there are ions with even more or less oxygens, we add the prefix per and hypo, respectively. Shakespeare once said, "What's in a name?" Well, when it comes to naming compounds, it can tell us quite a lot. When it comes to naming ionic compounds, we start off by naming the cation, which is usually a metal, followed by the anion. If the anion is monatomic, the last part of the name is replaced with the suffix "ide." So the compound CaBr2, which we discussed earlier, would be calcium bromide. In the same way, the compound K2O would be potassium oxide. For ionic compounds that contain polyatomic ions, the rules are the same, but the name of the polyatomic ion is not changed to ide. With these rules in mind, try naming the following ionic compounds. Well, how did you do? Remember that with transition metals, we can have several different charges or oxidation states. We may need to determine the oxidation state of the transition metal using the charge of the anion. For the last example, we see that we have 3 chloride ions, each with a -1 charge. The cation must be ion 3. For covalent compounds, the naming rules are slightly different. For now, we are going to focus on binary covalent compounds, which are covalent compounds with 2 different elements covalently bonded. In these cases, the element that has a lower group number is named first. If there are more than one atom of this element, we use prefixes such as di, tri, tetra, penta, and so on to indicate how many there are. The element with the higher group number is named second, again using prefixes to denote how many atoms are present, this time starting with mono to indicate 1 atom. Note that we do not use the mono prefix for the first element as in CO, which would be carbon monoxide. Now let's try naming a few covalent compounds. The last type of compounds we will be discussing are acids. Acids are compounds in which hydrogen is bonded to either a nonmetal, known as a binary acid, or polyatomic oxyanion, known as oxoacids. When dissolved in water, these acids release hydrogen ions. For binary acids such as HCl, we always start with the prefix hydro followed by the root of the nonmetal atom and the suffix "ic, followed by acid. So HCl, we would name this as hydrochloric acid. For oxoacids, we would take the name of the oxoanion and replace the suffix that end in "ate" with "ic, or the suffix that ending in "ite" with "us, followed by acid. For example, HBrO3 would be bromic acid because the oxyanion is bromate, where HBrO2 would be bromous acid because the oxyanion is bromite. Go ahead and try to name the following acids. Chemical names are purposely unambiguous, so you should be able to identify the chemical formula from them and vice versa. It is extremely important to understand the 2 main types of bonds which these different compounds are named. If you ever need to review these rules, please make sure to come back and rewatch this video. Until next time, have a wonderful day. Thank you.